Hi all. Here again are two definite integrals that would give you the area under a curve. In the first example, we have the area under x plus 2 over x over the interval from 1 to 4. The graph of that looks a little bit like that. And we have a second example to find the area under the curve 10 minus 2x plus 3 sine of x over the interval from 0 to pi. Sorry I don't have a picture for that, not quite enough room on my small makeshift whiteboard here. But what you might want to do is pause the video, try them on your own, and see if you can get the right answers before we demonstrate them. So assuming that you've paused the video and given a try on these integrals, let's go ahead and find the areas under these curves. So for the first one, find the integral of x plus 2 over x. The integral of x is a simple one, 1/2 x squared. And the integral of 2 over x would be 2 times the natural log of technically the absolute value of x. But we have values which are positive anyway, 1 and 4. And then we would evaluate that integral from 1 to 4. And do remember that when you do a definite integral, that it is not necessary to put the plus c because you are evaluating it at endpoints. And then evaluating these actually at the endpoints, we're going to get 1/2 of 4 squared, which is going to be 16 divided by 2, 8, plus 2 times the natural log of 4, minus the value at 1. 1/2 times 1 squared, you simply have a 1/2, plus 2 times the natural log of 1. And then simplifying this, we are going to have 8 minus 1/2, which is going to be 15 halves, plus 2 times the natural log of 4, which we could simplify into, by our properties of logarithms, logarithm of 4 squared, plus the logarithm natural log of 16. And remember that the natural log of 1 is actually 0. So 15 over 2 plus natural log of 16 actually is your final exact answer. Now this would be the exact answer. However, if you put this in the calculator, that would be approximately 10.273, approximately that to 3 decimal places. However, the exact answer would be 15 over 2 plus the natural log of 16, and that gives you the area under that curve from 1 to 4. In the second example, we want to find the definite integral for that again. So the definite integral, we integrate, we get 10x, and then the integral of 2x is x squared. And then we have the integral of sine. Remember that the derivative of sine is cosine, but the integral is negative cosine. So we get negative 3 cosine of x, and we're evaluating this from 0 to pi. So we want to then evaluate this integral at pi, and again remember that the plus c is not necessary if you're evaluating at endpoints. So we're going to have 10 pi minus pi squared minus 3 cosine of pi minus And now don't always assume that the value at 0 is going to be 0. It may not be. Of course it is when you substitute 0 into 10x and into x squared. But then we have 3 cosine of 0, and we're going to subtract those. Now remember what the cosine of pi is. The cosine of pi is actually -1. And the cosine of 0, remember, that's equal to 1. So it appears that we have, as our final answer, 10 pi minus pi squared. But what do we have in terms of just the whole numbers? -3 times -1, we get +3 there. Okay, then we get another minus -3, another +3, so for a total of +6. This is your final exact answer for the area under that curve over the interval from 0 to pi. And if we were to put that into our calculator, we would get approximately 27.546. But then again, that's a decimal approximation. The exact answer is 10 pi minus pi squared plus 6.